In our last tutorial, we spent time building a MultiSig smart contract in SmartPy using the SmartPy IDE. In this tutorial, we're going to be building the front end of that MultiSig contract. And to get started, we're going to go through what we're going to be building looks like. So we're going to walk through the application itself. And then afterwards, I'm going to show you how to code up your version of this MultiSig application. Also, over here, I've got the front end of my dApp. This screen lists all the proposals in the contract. Over here, you can submit a proposal, so you can decide how much you want to send to the receiver or how much you think that the MultiSig should send to the receiver. And you can submit the proposal for that. And over here, members of the MultiSig would be able to vote. And on this screen, we'll be able to fund the smart contract. So right now, we've got 16 Tez in the contract, and I'm going to connect my wallet first so that we can add more funds to the contract, and you can see how that works. So I've just clicked the connect wallet button, and now my wallet is connected. We've got 16 Tez. Let's make it up to 20. So I'm going to add 4 Tez to this. I'm going to click send funds, and it's going to take the funds from my wallet, and it's going to send that into the contract. And I'm going to sign this transaction by clicking confirm. And this is just going to take a minute to complete. And once that is done, you're going to see right on the screen, it's going to update to 20 Tez. So we now have 20 Tez in this contract. And then I'm going to come here and I'm going to submit a proposal. So let's say we want to send 10 Tez to this address. So this is one of my wallet addresses. You can see what the balance for this wallet address is. So it's the one ending in AFGZ, which is account 7. Right now, it's got 23 Tez inside. And we want to send 10 more Tez to it. So I'm going to click on submit proposal, and I'm also going to sign this action as well. So once I sign, remember that once you create a proposal, you also automatically vote on that proposal. And that's what's going to happen here. So let's wait for this proposal submitted. And if I come to see proposals, you can see that we have the 10 Tez. We have the receiver in 1 vote because I created the proposal. I automatically voted on it as well. And then the status is pending. So I'm going to disconnect this wallet, and I'm going to connect another wallet that is also a part of the MultiSig. So I'm going to connect account 2, click connect. And now that account 2 is connected, I'm going to be able to sign this proposal. So I'm going to click on the sign button, and this is going to ask me to confirm the transaction, and I'm going to confirm it or sign it. And once that is completed, you're going to see that number of votes is going to update to 2 because the entry point, the vote on proposal entry point knows that another vote has been added to this proposal. So remember that we need to get 3 votes, at least 3 votes for this proposal to be accepted by the MultiSig, and then for the funds to be sent to the wallet address. So I'm going to disconnect this again, and I'm going to connect another wallet. Remember that all of these wallet addresses are a part of the MultiSig, and that's why this works. So I'm going to connect my third wallet. And once that is connected, I'm simply going to sign the transaction again. Just click on the sign button, and this is going to ask me to confirm the transaction. So I'm going to click the confirm button, and once I click the confirm button, the same thing is going to happen again. But this time around, it's going to update to 3, and the status is actually going to change to completed. And there you go. So now the transaction is complete. And if I go back to my wallet, remember that I had 23 Tez in there. And if I open it up now, so it's account 7, you can see now that the balance has gone up to 33 Tez. And if I actually go into the activity tab of my Tempo wallet, you can see that I got 10 Tez, and it came from the contract address. You can see that the transfer was done from the smart contract. And if you also look at the smart contract on Better Call Dev or something like TZKT, you would also be able to see this activity within the smart contract. All right, so now we're done taking a look at what we're going to be building today. Let's get into the code. So I'm going to pull up my VS Code, and we're going to walk through the code. So the first thing we're going to do, we're going to clone the application. And when you clone the application, basically what you're going to have is that you're going to have the framework, or kind of like, what all of this looks like, which is the styling. The buttons are already styled as well. And what we're going to be walking through in this tutorial is going to be the logic for implementing this dApp. So let's get to it. Okay, so to get started, you can simply pull up your VS Code or your favorite terminal. I'm going to be using the terminal within my VS Code application, and I'm going to start by writing git clone. So this link is going to be in the description below so that you can simply just copy and paste it into your terminal. And simply what I'm going to have here is the git clone command that is going to clone into the application that I've already set up for you. So it's got all of the boilerplate code. It's got all of the styles. We're using Tailwind for styling in this tutorial. So once you're done git cloning, simply cd into the folder, MultiSig 2, and pull this up. So now that I have this here, I'm also going to run this application. So once again, I'm going to open up my terminal. So I'm going to run npm install first, which will install all of the packages that we're going to be using. And we're going to go through all of those packages in a little bit. And then I'm going to run npm run dev as well. And this should start our application on localhost 3000. Let's take a quick look at what our front end looks like. Again, very simple front end. Nothing is going on here. No logic has been applied. This is simply just a bare bone application. We've got all of the styles applied, and we're waiting for the logic within the application for it to actually start to work. So you see, if I click on font contract, we can actually see the font contract scene. And if I click on submit a proposal, we can see the submit a proposal screen. And see proposals, you can also see the see proposal screen. But right now, this information is just hard-coded in, and we're going to get into actually fetching things from the blockchain. Now, before we continue writing our application, we need to deploy our smart contract to the blockchain and get the contract address before we start writing the front end or the dApp for our application. And before we actually get to that point, we need to make some changes to the last smart contract that we wrote in the previous tutorial. And I'm going to walk through some of those changes now. And these changes are necessary for us to build something that allows us to work really well with Taquito on the front end and the React JavaScript library. So the first change that we're going to make is that we're going to have proposal keys set, right? So we're basically going to have an array that takes all of the proposal keys that are created within our smart contract. And the reason for that is because by design, the Tezos blockchain does not have an enumerable, right? So you can't have, when you have records on the blockchain, so for example, over here where we have our proposal types, when we create each of these records, right here we have the integer, right? We have an integer as the key for each of these records. But the way the Tezos blockchain works, it doesn't essentially have an enumerable that keeps track of each of these keys, right? And so what we need to do on our own side, we need to make sure that we're keeping track of those keys so that on the front end, which you would see later on, it's easy to simply fetch all of these records from the blockchain. And Tezos does that by design to optimize storage of large data on chain. So that's the first change that we're going to be making. Now, the second change that we're going to be making to our smart contract is that we're going to add, so just like we've pointed out here, we have created a set, and all of that data is going to be fed here when a proposal is being submitted, right? So remember that over here, we're increasing active proposal ID by 1, and it starts from 0 over here, and we're increasing it by 1 now. So every time a new proposal is submitted, we're going to take that key and we're going to store it in proposal keys, right? And we're basically just using active proposal ID to achieve that. We're going to store that in proposal keys. So we're going to have a set of proposal keys, which we can then use on the front end to pull data from the blockchain. One more change that we're going to make is that we're going to add the addresses of the members of our MultiSig. So for the purposes of this tutorial, I've simply added the wallet address of 4 of my wallets on Tezos. So I've got 4 different wallet addresses, and I've added them all here as members of the MultiSig for this tutorial. In the last tutorial, when we wrote this line with members, we had alice.address, bob.address, charlie.address, earl.address. But in this tutorial, we're taking away the address .address bit or object, simply because we already have the addresses hard-coded into the smart contract. So everywhere that we add .address, we're going to take that out and simply just pass in Alice, Bob, Charlie, and Earl. The only thing that we're going to keep constant will be Danny.address because we're still using the test account method from the SmartPy library. And if I run this again, you see that everything still works as normal. So if you go through all of this, everything still works as normal. And you're also going to have a copy of the smart contract in the description below as well. So you can also simply copy and paste and play around with the smart contract. Now that we have all of this done, let's deploy our smart contract to the Tezos blockchain. And to do that, you're going to go to deploy Mikkelsen contract, click on deploy Mikkelsen contract again. We're going to select the GhostNet as our network of choice. And I'm going to select a wallet to deploy the smart contract with so that we can pay gas fees. I'm just going to stick with this wallet, click validate, then click on estimate cost from RPC. Once that is done, click on deploy contract and accept. And then I'm going to sign the transaction. So once it's signed, you can see that I can now get the contract address. So I'm going to take this contract address and I'm going to take it into the front end of my application. So I'm going to go to components. No, actually, I'm going to go into hooks. I'm going to go into use Taquito, and then I'm going to paste my contract address over here. All right, so now with our contract address pasted in here, let's actually go through what each file does. Over here, we have our form input. So the form input is just the input that you see on the front end. So it takes in label, type, placeholder, name. So label is basically what users will see on the front end, what the button should be called. The type is the type of button. The placeholder is a placeholder text, and name is what the name of the button would be. So type could be either text or number, which you would see later on. And I can quickly show you what that looks like on the front end. So on the front end, if you're in submit a proposal, this is a form input. This is a form input right here as well. And this is also a form input in the fund contract screen. We've got the see proposals component, and on the front end as well, you can see what that looks like. This is simply a table that displays all of the proposals that has been submitted by members of our MultiSig to the blockchain. Sidebar is also the sidebar on the front end. So if I pull that up over here, you can see all of the menu buttons are also on the sidebar. And here we're going to have our wallet where we can connect and disconnect. But I think the most important file here is the use Taquito file, which actually contains all of the logic for our application. And let's go through each of the imports first, and then we'll go through the logic for the code. So Beacon Wallet would connect to the user's wallet on the chain, and then we can interact with that wallet. Our application can interact with the wallet. Taquito allows us to interact directly with the blockchain, and then the Beacon SDK allows us to basically determine the network type that we want to use. And then, of course, we import use state, use ref, and use effect from React, which are all React hooks that we're going to be using within our application. We've got the RPC URL, and we're using this RPC from ICAD Infra for the purposes of this tutorial. We've got our contract address from what we just deployed in the last couple of minutes. And the first thing we're going to do is we're going to create a new Tezos instance, right? And we're going to pass the RPC URL in there. And then we're also going to select the network type, and we're using the ghostnet for this tutorial, not the mainnet. Remember that you only use the mainnet when your application is live and ready for users to use. We're also going to have a couple of functions, right? So we're going to have the connect wallet function, which allows users to connect their wallet. This connect wallet function to disconnect the wallet. Get smart contract storage will allow us to fetch information from the blockchain. Set smart contract storage is going to allow us to submit information to the blockchain, particularly when we're submitting a proposal to the blockchain. So that's what this function is going to do. And then send funds to smart contract, which is going to allow us to send funds to the smart contract. And then in the end, we're going to export all of this information, and our pages and index.tsx is going to pick this up. Right, so we're going to pick up all of this. So things like contract address, things like the connect wallet button, all of those functionalities will be exported by the use Taquito hook, which we've created by ourselves. And then we're simply just going to pass all of that into our components in here. This just makes our code more readable, easy to read, easy for anyone to work with, and just makes it a lot more simpler. All right, so so let's get into the implementation for this. All right, so we've got our wallet address here. We have a state to hold our wallet address so that we can display that to users on the front end. We also have a state to hold proposals. And the next thing we're going to do, we're going to also have a state to hold whether or not the user's wallet is connected. And then we're going to have a state to hold loading, right? So anytime we have any loading screen within our application, we'll have a state to hold that state. And then we also have a state to hold our contract balance. So we want to be able to display how much is actually within the contract. And then we want a state to reload the screen so that the screen knows when to be prompted to reload the UI so that the user can see the latest data on chain. We have another state for messages. And this state will allow us to basically set the type of message. It's an object. Set the type of message and then also set the message as well. So the message is whatever the users can see on the screen, letting them know what is going on within the application. And then we're going to have a use effect. So the use effect is going to work when the application loads, and it's also going to work anytime reload screen is set to true. So let's take a look at that. So when the screen loads, we want to call the get smart contract balance function, which we're going to write later in our application. And this function will simply go to the blockchain, look at the smart contract and get the balance of that smart contract and then display to the user. And then we're also going to get a storage as well. So the storage basically is all the proposals on chain. We can fetch that information and display it to users within our dApp. And we're also going to basically repeat the same operation anytime reload screen is true. So if we want to basically reload that screen for users to see again, we'll simply set reload screen to true. The information is going to go, Taquito is going to go back to the chain, fetch the latest data, and then display it to the user. Now, let's start working through our connect wallet function. So within our connect wallet function, we're going to have a try catch. So it's an async function. And the first thing that we want to do is we want to create a new Beacon wallet instance. So when the user clicks on connect wallet, we're going to create an instance, or we're going to instantiate Beacon wallet for the user, right? So we let Beacon wallet know that we're working with the GhostNet here. Remember that we already set network as GhostNet up here. And then we also pass in the name of our application. This one is just simply going to be called the MultiSig dApp. And then we request permission from the user so that we can interact with the RPC that we defined earlier within the application, which is this one from ECAD Infra. And again, we're working with the GhostNet here. And then we set the wallet state. We're going to be using the useref here, and we'll define this later on in the video. So we're basically just going to be using useref from React over here. And then we're going to have the address as well. So when we call this getPKH method on the wallet method, or on the wallet instance, we're going to get the wallet address. And this method simply gets the public key hash, or the public wallet address for the connected wallet. So we're simply going to take that information, and we're going to we're going to get that information, which is the address, and we're going to set wallet address to that address so that we can display it to the user on the front end. And then we set it's connected to true. And then if we want to log out what the address on the wallet is, you can also do that as well. And if there are any errors, we'll log that out as well. Now, our disconnect wallet function is simply going to allow the users to disconnect their wallet. So if you tap the button, the wallet disconnects. And if you click the button again, the wallet connects. And we're going to check if there's an existing wallet. So if walletref.current is not undefined, and if it's not undefined, we're going to clear active account. So this is the method on the Beacon wallet that allows us to disconnect the wallet. We set wallet address to empty, and then we set disconnected to false. And then we're going to have this simple function that is called asConnectWallet. And this function, all it simply does is just checks if a user's wallet is not connected, simply tell them to connect their wallet. That's simply all it does. And then we're going to have another function that sends funds to the smart contract. And every time we interact with the Beacon wallet library, it's always going to be using an async function, right? And we're always going to be waiting for responses from the blockchain. And before we allow users to try to send funds to the smart contract, we need to check if they have a connected wallet first. And if they don't, we're going to display this connected wallet message. And then we check if there's an amount being passed in the function. If there is, we're going to set up a try catch. Loading is going to become true so that the user can see that the state is loading. So first, we're going to get the contract by passing in the contract address here. We're going to connect our Tezos instance to it. And then we're going to call the deposit endpoint, right? So we've got the deposit entry point within our contract. And anytime we want to send funds to the smart contract, we need to call this deposit endpoint before we can do that, right? And then we're going to call the send method as well, and then pass the amount that we want to send. And then we wait for the confirmation just to make sure that, whatever information we're sending to the chain has been confirmed. And then finally, we display a message to the user saying funds sent to the smart contract. And then we set reload screen to true so that the screen can reload. Remember that we already have that implemented within our use effects up here. And then we set loading to false. And then if there are any errors, we can display that to the user using our set message state again, display that to the user. And so the next function that we're going to have is going to be the getting the smart contract storage. Now, all we're simply doing here is that every proposal within our contract, we want to be able to fetch that and then display it to the user. And to achieve that, we're going to have a try catch block again. And we're going to start off by setting loading to true. And we're going to have an empty array here that's going to take a list of all our proposals. And again, we're going to make a request to, we're going to use the Tezos instance from Taquito. So once we get the contract, the next thing is to get the storage for the contract. And we're going to call the storage method on contract, which is going to give us a storage on the chain. And then we're going to get all of the proposals within that storage. Now, for us to fetch all of the proposals within the storage, we actually need the keys for each of those proposals to be able to fetch them, which we spoke about earlier. And what we're going to do is we're going to get the keys from proposal keys, which we modified in our smart contract. And then we're going to call promise.all. And then we're going to pass the proposal keys. We're going to map through each of those proposal keys. And we're going to map through each proposal and actually fetch the proposal. So once we fetch the proposal, we're going to push it into the proposals array, which we've got defined up here. And we're going to push, the proposal, they've got the payment amount, they've got the receiver, and they've got the status as well, which is true or false, that the voting has been completed. So all of this information is going to get pushed into the proposals array up here. And if we actually have anything in there, if the proposals array is greater than 0, we simply set proposals to proposals array, and then we can now display this to users of our application. So loading goes to false, and then if there are any errors again, we will catch those errors. We're going to set the smart contract storage as well. So the first thing that we do is we're going to ask the user to connect their wallet again. So if they're not already connected, we're going to prompt the users to connect their wallet. And then once their wallet is connected, again, we're going to go through the same process. We're going to get the contract first, and then we're going to call the submit proposal method on the contract. Now notice here that we're using this methods object because we want to pass the payment amount and the receiver as an object, right? So we're calling the methods object method from Taquito, which is on the contract instance. And then we're going to call the send. So send actually is what sends the operation or sends the transaction to the blockchain. And then we await confirmation, and then we set the message as usual. And then again, of course, always handle errors within your application. And for our get smart contract balance method, again, we go to the blockchain. We're going to convert the balance number because balance is always going to come back as a big number type. And for us to display to our users, we convert it to number and divide it by 1 million because this number comes back in Tez, which is the smallest unit of Tez. And for us to convert it to Tez on the front end, we simply just divide by 1 million and convert it to Tez. And lastly, we're going to have the vote on proposal method. And this method is going to allow users to actually vote on the proposal. So up here, we have the submit proposal entry point. But in this one here, we're going to have the vote on proposal entry point. We fetch the vote on proposal entry point on the contract, and then we call the send method. And again, we await confirmation, just like we've done in every time we're interacting with the chain itself. We display a message to the user saying vote accepted if everything is fine. And if everything is not fine, again, we catch the error and then we display that message to the user. And finally, once all of this is done, we need to export all of the states that we have in here. So we've got the is connected state, we've got the send funds smart contract function, we've got the set smart contract storage function as well. So export that, export loading, export the message, export the contract balance, and export vote on proposal. And lastly, before we wrap this off, we need to bring in our useref as well. Because remember, we have walletref.current here, but we don't have that defined up here. So that's what we need to do next. So we need to set our walletref first of all by calling useref. So useref is a React hook. So we don't want to re-render the UI. We just simply want to hold the walletref instance without re-rendering the UI. And that's why we're using the useref here. And the final thing that we're going to do here is that once our walletref instance is set, once it's not undefined, once it's actually set, then we can simply pass that instance to the set provider. So the set provider method on this Tezos instance is simply how you want to interact with the blockchain, right? So we want to interact with the blockchain using the user's wallet. And then for us to be able to do that, we need to set the provider by passing in the wallet instance to the wallet object on Tezos.setProvider. Right, so with all of that done, we can simply save this, and then we can head over to index.tsx, and we're going to make changes here as well. So the first thing that we want to do is we actually want to import everything that we've exported here. We're going to copy all of this, come into index.tsx, and I'm going to paste it in here, and I'm going to save. Now, let's start to put all of this, pass all of these methods into our components. So the first thing, we're going to take our proposals from here because proposals is already defined. The next one is wallet address. So let's see, wallet address should go over here at the sidebar. Then connect wallet, right? So connect wallet, we can put connect wallet in here. Disconnect wallet, so you can put disconnect wallet here as well. We've got contract address, proposal, those are already done. It's connected, so we're going to pass the is connected method here as well, or the state. Send funds to smart contract. Now, over here, we have our undo submit, which is, and we have also got undo submit send funds. So undo submit send funds is what is the function that when the user clicks the button, it sends the funds to the smart contract. So what we're going to do here, I'm going to take this out and I'm going to write send funds to smart contract. I'm going to pass the value, right? So this is done. And then the next thing is set smart contract storage. So set smart contract storage, remember that this is where we call the submit proposal entry point. So I'm simply going to write that here as well, set smart contract storage. And this takes receiver and payment amount as arguments. So I'm going to copy this, takes the receiver and the payment amount. So remember that all of this is actually coming from our input on the front end. So paste that in there, and I'm going to remove our logs. And those two are done. I'm simply going to close them up. And then we've got loading as well. So let's see, loading goes in here. So I can use Command D to highlight both and then pass loading into both of our components here. And then we've got message. So messages go here. So I'm going to replace this with very simply message.message. Save that as well. And then we've got our contract balance. So contract balance is over here. So on our send funds to contract screen, we also display the contract balance. And we're going to take that from our use Taquito hook, and then we're going to pass it in here. And finally, vote on proposal. So vote on proposal is the last method here. And I'm going to delete this, and I'm going to pass vote on proposal. Now, our entire application is all set, and we're ready to go. So let's go to the front end of our application and make sure that everything works correctly. So to make sure that your application is still running, simply go to View and bring up your terminal. Let me go to Node. Okay, everything looks good. My application is still running. And I can go to the front end. Now, when we go to the front end, you can see that there are no proposals because there are actually no proposals in the smart contract. Submit a proposal, fund contract. You can see that the balance is 0. So we're going to connect our wallet. All right, so before we connect our wallet, we can get our smart contract address, and we can go to Better Call Dev, which is a smart contract explorer for the Tezos blockchain. Now, anytime you've got a smart contract, you can simply come to Better Call Dev to see what's going on within the contract. And you can see that this contract was deployed. You can see the address that deployed the contract. You can see the contract balance. You can see when it was last active. You can also see when it was originated as well, right? So the first thing that we want to do in our dApp is that we want to fund the contract, right? So I'm going to connect my wallet first. And as you can see, beacon is what connects to your wallet. So you can have, let me just show this again. So once I click on connect wallet, you can see we can connect to Kukai, we can connect to Temple, we can connect to Plenty and to Umami, and there are even more. So there are a number of wallets that you can connect to using Beacon, and Beacon is kind of a wrapper around all of these wallets that allows us to interact with any of these wallets that users decide to connect to. But for this tutorial, we're going to be using Temple, and if I click on Temple, I'm going to click on connect now, and now I can connect my wallet. So my wallet is connected now, and I'm going to send 5 Tez to the smart contract. I'm going to click on send funds, and it's going to prompt me to sign the transaction. I'm going to click on confirm. This is going to change from loading back, and it's going to display a message to us up here. So funds sent to contract, and you can see that this has updated to 5 Tez. And if I go to Better Call Dev, and I refresh the Better Call Dev screen as well, you can see that our balance is now 5 Tez on this smart contract. And just to be clear again, this is JN97, and our contract also ends in JN97. All right, so now that we've got that done, we can actually submit some proposals, right? So let's try to send, let's say 3 Tez, right? And we want to send 3 Tez to this address here. And I'm going to click on submit proposal. So I'm going to click confirm. And when I click confirm, it's going to send a proposal to the smart contract and proposal submitted. So if I come to the see proposal screen, you can see that the proposal has been submitted for 3 Tez. This is the receiving address. This is number of votes, and the status is still pending. Now, I'm going to disconnect this wallet, and I'm going to connect a new wallet so that we can have another user or another participant in our MultiSig sign the proposal. So I've connected another wallet ending in UVZD, and I'm going to click on sign. And when I click on sign, it's going to prompt me to sign the transaction. I'm going to click confirm. And it's going to update the number of votes here to 2 as well. All right. And lastly, we're going to connect the third wallet. And let me click connect. And before we go on to that, let's go back to Better Call Dev. Let's refresh. You can see the deposit entry point was called on our smart contract. The submit proposal entry point was called on our smart contract as well. And the vote on proposal entry point was also called on our smart contracts, right? So you can see that everything is working as it should. All right, so let's finish this up. So I'm going to click on sign again. And when I click on sign, it's going to ask me to sign the operation or sign the transaction using my wallet address. So I'm basically using the private keys of my wallet to sign this. So I'm going to click on confirm again. And when I click on confirm, So give it a couple of seconds while it pings the blockchain. And then when all of that is completed, you're going to see the number of votes is going to get updated to 3, and the status becomes completed, and now you can no longer sign the transaction again. And to confirm that everything actually works, we can go to Better Call Dev and see what's going on. So we go to our Smart Contract Explorer, which is Better Call Dev. And if I refresh this, you can see that 3 TES has been withdrawn from the smart contract. And the balance of the smart contract is now 2 TES, right? And if I open this up, you can see where the money went. So the destination is a wallet address ending in AFGZ, which is a wallet address that I have access to, and 3 TES was sent to that wallet address. And if you go into storage as well, you can also see the proposals. You can see that only one proposal has been created. And if I open up these proposals here, you can see that the payment amount was 3 TES for that proposal. The receiver also ending in AFGZ. And then these are the voters, or these are the members of our MultiSig who have voted on this proposal. And voting complete is set to true. That is simply how you implement a dApp or a decentralized application for a MultiSig using a MultiSig smart contract. You saw earlier in this tutorial that we made some changes in our MultiSig to allow us to be able to work better with our smart contract on the front end. So for example, we needed to create proposal keys, basically fetch all of the proposals that are within our smart contract using those proposal keys. So that's also a very important lesson to learn. And then once that is done, you simply use Taquito and you use the Beacon wallet to interact with the wallet and to interact with the blockchain. And once all of that is done, you can have a full-fledged application for users of your dApp. And that brings us to the end of this tutorial. If you've enjoyed watching this tutorial today, make sure to like and subscribe, and you will always get great content.